What if, at the very heart of the universe, the glue that holds everything together and allows everything to work is less complicated and mysterious than we ever imagined? Imagine peeling back the layers of reality, past matter, past energy, past even space and time, and finding something that wasn't expected: code. Not an endless stream of ones and zeros like in the Matrix, but rather mathematical structures that behave exactly like digital code we use to transmit and correct information in our digital world. This is not science fiction. It's a discovery that surprised even the most skeptical scientists and suggests that the universe might be built on a hidden layer of information, an underlying framework of cosmic code embedded in the very laws of physics. The most well-known basis for this theory came from theoretical physicist James Gates. While studying high-level mathematical constructs meant to unify the particles and forces of the universe, also known as supersymmetry equations, he uncovered something very peculiar. Hidden inside the equations were patterns identical to error-correcting codes. The same kind of codes that ensure digital messages sent across the internet arrive intact. Gates described it as though the equations themselves contained a kind of self-correcting mechanism, like a built-in quality control system. It was as if the laws of physics were written with the same logic we use to keep computers from crashing. This discovery raised questions that feels more like philosophy than physics. Why would nature need error-correcting codes? Is the universe built on information that needs to be protected? It's not the only place where the universe seems to hint at an informational structure. In black hole physics, information plays a prominent and central role. When matter falls into a black hole, it seems to utterly vanish. But quantum mechanics states that information can never be destroyed. It's a law that binds our universe. This paradox gave rise to the holographic principle, which suggests that all the contents of a region of space can be fully described by information stored on its outer boundary. It's as if the entire universe is a three-dimensional projection generated from a two-dimensional layer of data, like a cosmic version of a computer-generated image or movie. And when you dive into quantum mechanics, the mysteries multiply. Entanglement looks less like a physical link and more like shared information. The entire quantum state of the universe is, at its heart, an informational framework that unfolds and evolves according to mathematical laws. If these clues are taken seriously, they suggest that information might be more fundamental to the structure of reality and the universe than even matter or energy. Atoms, particles, and even space-time itself could come from a deeper layer of hidden mathematical rules that creates the reality we live in. Think of it this way: a video game appears solid and real to the characters within it, but at its core, it's only a set of mathematical instructions running on a digital system. The universe seems to work in a similar way. This doesn't mean it's proof we're living in a literal digital simulation, but it does suggest that reality follows logically based mathematical rules in a way that's eerily similar to how a computer processes information. What's even more surprising is information behaves as if it's a real physical part of the universe when it comes to physics. It carries weight, takes up space, just like information on your computer hard drive, and it even shapes how matter and energy move and behave, because the information is woven into the very fabric of reality. Even black holes, the most extreme objects in the universe, have to obey this rule. When something falls into a black hole, the information related to it is never lost. Instead, it gets encoded onto the black hole's surface, like the ultimate cosmic hard drive. This strongly suggests that information isn't just an idea we use to explain the universe. It's one of the basic ingredients that make up reality itself. Information is also fundamental to entropy, which is the measure of how things gradually lose structure and order over time. The more information you have about a system, the more organized it remains. But ironically, information is also subject to entropy. As it degrades or is lost, the system drifts toward greater randomness and disorder. And because entropy is tied to the arrow of time, information plays a key role in how time moves forward. Time flows in one direction because information keeps degrading, dispersing, scattering, and becoming harder to maintain within a single system. So information isn't just something in the background. It plays an active role in how the universe develops and moves forward through time, second by second. And in James Gates's work on supersymmetry, the fact that these codes showed up on their own suggests they weren't just random or an accident. They may very well be necessary for the stability of the universe itself, the way a computer operating system has to use error-correcting codes, or it crashes. Without this hidden code, the universe itself could begin to unravel into chaos. So what does this mean for our understanding of reality? It could mean that what we call the laws of nature are not just descriptive, they're prescriptive. They are the operating rules of a deeper informational layer. The real question becomes that if we ever fully decipher this code, could we manipulate it? Could we rewrite it? Could we bend space-time, alter matter at its foundation, even rewrite the physics we take for granted? For now, the idea sits somewhere between science and science fiction, but it is rooted in real mathematics and logic. It also touches on an unsettling philosophical idea. If the universe is built on information, does that mean it's just a natural random process, playing out like a giant calculation? Or is the universe something that is intentionally designed? James Gates stopped short of calling his discovery proof of a simulation, but he did admit it was a shock to the system to find the same structures in physics that we use in human-made computer systems. It could be coincidence, or it could mean our universe really does resemble a kind of vast self-correcting program. For now, we can't say definitively that the universe is code in the way we think of software. But there is a growing sense among physicists that information is not just a property of reality, it is reality. If we ever learn how to read and rewrite this cosmic code, everything changes. We would no longer be limited by the basic rules of physics as we know them. We would become the architects of the universe and reality itself. We would, in essence, become God. This is a godless universe.